In this lesson, we will learn how to factor trinomials. So let's make the distinction between the different types of trinomials we will see in this video. Now, the first one is when a is equal to 1. So that means that the coefficient of x squared is going to be 1. So let's see how we can factor something like this. Now, when a is 1, you can think of this as a mental math problem if you're good with numbers. So it's a mental math problem. Once you figure out two distinct numbers, there you go. Your factoring is ready. You don't have to do any extra steps. So how can we figure out these two numbers? We always look at c, which is in this case the negative 21. Now, we always multiply the a times the c to figure out what that number is, the negative 21. But since a in this case is 1, and 1 times any number is itself, we can just disregard the a in this case and just look at the c. So I need two numbers that would multiply to give me c, which is in this case negative 21, and I need two numbers that would add to give me b, which in this case is negative 20. And they have to be the same numbers. Like, for example, if I think of two numbers that multiply to give me negative 21, I have to use those same numbers and they should add to give me negative 20. Okay, so let's review. What numbers am I looking for? I want something that will multiply to give me AC. But since A is 1 in this case, so I want two numbers that would multiply to give me C, so put a dot on top of the negative 21. And I need those two numbers to also add to give me b, so put a plus on top of the negative 20. So what are those numbers? What can you multiply to give you negative 21? Let's put negative 21 on the side and let's think of all the numbers that would multiply to give me negative 21. And these numbers have to add to give me negative 20. So let's think. I know that 3 times 7 is 21, but I want one of them to be a negative. So negative 3 times 7 is negative 21, but let's add them to see if that would give me negative 20. It doesn't, so then that is not the number because negative 3 plus 7 is a 4. What else multiplies to give me 21? 21 if I multiplied by itself. So 21 times 1, that would give me 21. So I want one of them to be negative. Let me put the 1 to be negative. So 21 times negative 1, that's a negative 21, correct. Now if I add those though, I get plus 20, and I want negative 20. So what I do is I just switch the signs. That means I don't want 21 and negative 1. I want negative 21 and 1. So these are the two numbers. So the two numbers are negative 21 and 1. Negative 21 and 1. So let's double check. If I multiply negative 21 times 1, that gives me negative 21, check. Negative 21 plus 1, if I add those, that gives me negative 20, check. So then these are my two numbers. Then I'm done factoring. I just put an x in front of each one of them, each number, and that would be my factor. So the first factor is x minus 21, and my second factor is x, and the 1 is a positive, so plus 1. And there you go, I just factored. Now this tree, you don't have to do it if you directly know what the two numbers are, but if you are stuck, this table will help you write down all the factors, see them, so you can add those factors and see which one do you want. So let's review. It's always a times c, but since a is 1 over here, so I need two numbers that multiply to give me c and add to give me b. If I can't think about them, I create a tree to help me figure out what the factors are. Once I figure out the numbers, I'm done. Then my first factor is x minus 21, and my second factor is x plus 1. Now let's move on to number 1. Now always remember, every time they give you a problem that you need to factor, always check if there's a GCF first. Factor out the GCF because then you will make the problem 10 times easier, okay? So I can see that the A and the B and the C are all divisible by 6, so I can factor out a 6. Now, if I factor out a 6 out of 6m to the power 2, I will be left with m to the power 2. If I factor out 6 out of 12m, I will get 2m, because 6 times 2 is 12. If I factor a 6 out of the 6, a 1 will be left. Don't forget that. It's because 6 times 1 is a 6. It's not a 0 over here or nothing. This number cannot disappear. If we have 3 terms, I should have 3 terms inside the parentheses. Okay? Now, with that said, now, do you see how A is 1? So then I need 2 numbers that would multiply to give me C and add to give me B. Very simple. Why am I not saying A, C? Because A is 1, and 1 times whatever is the number itself. So C in this case is 1. So let me replace the C with 1. I want 2 numbers that would multiply to give me 1 and add to give me B, which is 2. So multiply to give me 1 and add to give me 2. Now, what multiplies to give me 1? The only thing I can think of is 1 times 1 is 1. So let's see if this works. So 1 times 1 is 1, and 1 plus 1 is 2. There you go. These are my factors. So then my first factor is going to be x, or m, since the variable over here is m. So m plus 1, and the second one is m plus 1. Now, m plus 1 and m plus 1, this is basically m plus 1 to the power 2. Now, don't forget to copy down the GCF, and that would be your final answer. Now, I would like you to take some time to try to do number 2 on your own. So please pause the video and try it on your own. Now, by looking at this problem, the first thing I need to see, is there any common factor? I don't see any common factors, so I can't take the GCF. The second thing I check is this is a trinomial. You see how it's 3 terms? So the first thing I check for is A 1 or is A different from 1? A is 1. So then this is a mental math problem. Once I figure out the numbers, I am done. I don't need to do any extra work. So I need 2 numbers that multiply to give me 5 and add to give me 6. So 2 numbers that multiply to give me 5 and add to give me 6. What are they? Now, what multiplies to give me 5? 5 times 1 is 5. 5 plus 1 is 6. So there you go, I'm done. So then my 2 factors are x plus 5 and x plus 1. And that is my factored form. Now remember, if you want to check your work, you can always distribute. Now if you have an access to a calculator, you can put the standard form in y1. You can put what you got, your factored form, in y2, and then you graph it. If you get the same parabola, it means your answer is correct. If you get different parabolas, it means you didn't factor correctly. Okay? Now let's move on to number 3. Now number 3 is a little bit challenging. I wanted to add this question because I see it a lot on the SAT. So the first thing I want to see is, do you see how this factor, x plus 3, is to the power 2? And the same factor over here is x plus 3. It's the same thing. So what you do in this case is you replace the factor x plus 3 by a variable, whatever variable you want. What's your favorite letter? Let's say I want to use t. So let t equals this factor x plus 3. So I'm trying to simplify the problem and change it into something that I'm familiar with and something that I can factor. So now instead of the x plus 3, I can put a t. And now the t is being squared. Now plus 6. And instead of the x plus 3 over here, I can just put t, because I said let t replace x plus 3. So I can make it easier, and I can actually factor it faster. And I can just copy the plus 5. So do you see how I changed a complicated problem into something that I can solve? Do you see how this is very similar to the problem I did earlier? Do you see that? X squared, 6x, 6t, 5. So I wanted those two problems to be similar so you can see the bigger idea. So when they give you something like that and you see that the first factor is being squared and the second term has the same factor, you can just replace it by whatever letter that you want and change it into something that you are familiar with. Now you can factor this. Now, do you see how this is a trinomial and that the t-square has a coefficient of 1? So that is a factoring of trinomial where a is a 1. So you need two numbers that multiply to give you 5 and add to give you 6. So what multiplies to give you 5? You can go through the same process and add to give you 6. We figured out that the two numbers are 5 and 1. So then my two factors are t plus 5 and t plus 1, since I'm using the letter t now. Okay, there you go. I factored this problem. Now, the last step, you need to replace the t by what you assumed it is. So what did I say at the beginning? Let t be x plus 3. So once I factor it and I'm done factoring, I can now replace t by x plus 3. You see that? So now it's x plus 3 plus 5. And the second factor, I can also replace the t with an x plus 3. And then I put the plus 1. You see that? Now let's try to simplify what's inside the parentheses. So x plus 3 plus 5, I can actually add 3 and 5, and I get x plus 8. And if I add 3 and 1, I get x plus 4. So there you go. That's my factored form. So if you have something like this, and you will have something like this on the SAT, a lot of students are tempted to FOIL, write x plus 3 twice, and distribute the 6, and then combine like terms and factor whatever they get from that. Now, yes, you will get the same answer, but it's a long process, and you need to be faster on the SAT. So if you get something like this, and you see that the same factor is repeated, just replace it with a variable, whatever variable that you want, factor the new polynomial, and at the end, once you get the factored form, you can replace t by whatever you assumed it is equal to and simplify. And that would be how you simplify or factor a problem like this. In this video, we will talk about factoring trinomials, which means 3 terms, anything in the form of 3 terms, when a is different from 1. And the method we're going to be using in this video is the grouping method. Now, there are other methods, but the first method I would like to discuss with you is the grouping method. So what do we do if we have an a in front of the x squared? In order to factor something like this, where x squared has a coefficient, we need to start by multiplying the a and the c. So a times c in this case is a negative 36. So what I need to do is to find those two numbers that multiply to give me negative 36 and add to give me the b, which is negative 5. So put a plus sign on top of the negative 5. And put a dot on top of AC. So two numbers that multiply to give me negative 36 and add to give me negative 5, which is the B. So two numbers that multiply to give me AC, A times C, and add to give me B. Now, in order to find those two numbers, you need to list all of the factors of negative 36. Now, you might be good with numbers and be able to figure it right away, or you might need to list a couple of factors until you find it. So let's start with 1 and 36. Now, 1 times 36 is positive 36, so I need one of them to be a negative. Now, this will multiply to give me negative 36, but I need them to add to give me a negative 5. So let's add negative 1 and 36. That will give me 35. So that is not my choice. Now another number is 2 times 18. 2 times 18 is a 36, and I need one of them to be a negative. Now let's add negative 2 plus 18. That will give me 16. And I don't want that. I want negative 5. So let's move on. Let's think of the number 3. So 3 times 12 is a 36. So negative 3 times 12 is a negative 36. But they add to give me 9. So you see how I'm getting closer? So that's not what I want. So let's move on. 4 times 9 is 36. But I need one of them to be negative. So negative 4 times 9 is negative 36. Now they add to give me a positive 5. I need a negative 5. I got the number, but not the sign. So what I need to do is just switch the sign. So 4, negative 9. So 4 times negative 9 is a negative 36. And if I add 4 and negative 9, that will give me a negative 5. So these are my two numbers, negative 9 and 4. After I find the two numbers, I split the middle term, which is in this case a negative 5x. I split this term into two terms. One of them is the negative 9x, and the second one is the 4x. Where did I get the negative 9 from and the 4 from? These are the two numbers I found. These are the two numbers that multiplied to give me negative 36 and added to give me negative 5. So I copy the first, turn down. I split the middle term, which is negative 5, into the two numbers I found, which are negative 9 and positive 4. And I copy down the constant, which is negative 6. Now after I do that and I write down all the 4 terms now, I group the first two together, which is 6x to the power 2 minus 9x. I copy down the sign, which is a positive, and I group 4x minus 6. Now from here, this is just a GCF problem. You look at those two terms that you have grouped, and you ask yourself, what's common between them? I can see that 6 is divisible by 3, 9 is divisible by 3, so 3 is a common factor. X to the power 2 and x, so x is a common factor. You always take the variable with the lower power. If it's x, it means it's x to the power 1. So 3x is in common. So if you divide 6 by 3, you are left with 2. It's x to the power 2, and you factored an x out, so only one x is left. Negative 9x, so negative 9 divided by 3 is a 3. Now the x is factored out, so there is no x left over here. This is how you factor the first two terms. Now let's move on to the next two terms. What's common between them? 4 is an even number, 6 is an even number, so there's a 2 in common. 4x has an x, but 6 has no x, so there's no x in common. So the only thing in common between these two terms is a 2. So 4 divided by 2 is a 2. Since I did not factor the x, so I copy it down. I copy down the minus, and then 6 divided by 2 is a 3. So this is how you find the GCF out of those two terms. Now, if you are doing everything right, the two terms inside the parentheses will be exactly the same. So it's 2x minus 3 and 2x minus 3. What you do after that is that you write down that the first factor is going to be 2x minus 3. There you go. And the second factor is going to be the two terms on the outside, which is 3x plus 2. So those will create your first factor, and the 2x minus 3 will create my second factor. Okay? So then my factored form is 3x plus 2 and 2x minus 3. A common mistake that students do is that they look over here and they see that there is 2x minus 3. So they put 2x minus 3 to the power 2. Now that is wrong, because like what you think about is that 2x minus 3 is in this term, so, and it's also in here, so there's something in common, which is the 2x minus 3. And then the 3x and the 2 create your second factor. It doesn't matter how you write it, so if you write it as 2x minus 3 into 3x plus 2, that would be also correct. Now let's move on to the example over here where I gave you all the steps. Now, I would like you to pause the video and try this one on your own. Now, the first thing I need to do is to find what A times C is. So A is 12, and C is 2. So A times C is a 24. And so I need the factors of 24 that would add up to the B. The B is a negative 11, and add up to negative 11. So I need two numbers that would multiply to give me 24 and add up to give me negative 11. So something that would multiply to give me those and add to give me the middle term. Now, for me to find those numbers, let's think of all the factors that make up 24. So what multiplies to give me 24? 1 and 24. But if you add them, you will get 25. So that is not what I want. What else multiplies to give me 24? 2 and 12. 2 times 12 is a 24. But if I add them, that will give me 14. You see, I'm getting closer. So that's not it. But then I realized that every time I'm using those numbers, I'm getting positive numbers. But 11 is negative. So that means whatever choice I put over here, it has to add up to a negative number. So what multiplies to give me 24? So now, to get a positive 24, you have to multiply two negative numbers, because negative 2 times negative 12, negative and a negative, if you multiply them, that will give you a positive, and that's positive 24. So if I add those two numbers, I get negative 14. So that's not what I want still. Okay, what else multiplies to give me 24? 3 times 8 multiplies to give me 24. And they add up to give me 11. You see how the number is there, but it's negative? So that means if 3 times 8 is a 24, I know that negative 3 times negative 8 is also a positive 24, because negative times negative is a positive. Now when I add negative 3 and negative 8, that would give me negative 11. So there you go, I got what they wanted. And the two numbers are negative 3 and negative 8. So I found the two numbers. Now what do I do after that? I copy the first term down. I split the middle term into those two numbers. So instead of negative 11, I need to write negative 3x minus 8x. And I copy the constant down. That's called the grouping method, okay? Because now what I'm going to do is I'm going to group the first two together and the last two together and try to find the GCF and factor the GCF out for each of those two. So if I look at 12x to the power 2 and negative 3x, I know that 12 is divisible by 3. If I divide 12 by 3, I will get a 4. And I know 3 divided by 3 is a 1. So let's factor 3 out. If you factor 3 out, 12 divided by 3 is a 3. Minus 3 divided by 3 is a 1. So I'm going to put a 1 over here. Now let's think about the x's. Now this is x to the power 2 and this is x. So this is a double x, like not double x, basically it's x times x. And this is just x. So there is an x in common. 12 has x to the power 2. If I factor an x out, there is an x left. Now, this has an x, but I factored the x out, so this will have no x. Do you see how I factored the whole thing out? So I don't put a 0 over here. I always put 1, because if I want to FOIL or distribute, it should give me exactly this. So 3 times 3 is not 12, so I made a mistake over here. This should be a 4. Okay, so 12 divided by 3 is 4. So see how it's always good for you to check. We all make mistakes, so always double check by distributing. So 3 times 4 is 12. X times x is x squared. 3x times negative 1, that's your negative 3x. Now, if you look at those two, I can see that 8 is even, 2 is even, so both of them are divisible by 2. But do you see how the first term has a negative in front of it? If that happens, if the first number in the parentheses is a negative, always factor the negative out. So then negative 2 is in common. So negative 8 divided by negative 2 is a positive 4, so 4x. Now 2 divided by negative 2 is a negative 1. Now remember, you can use, if you have access to your calculator, you can divide on your calculator. So 2 divided by negative 2 is a negative 1. Always distribute to double check. Negative 2 times 4x, that's negative 8x. Negative 2 times negative 1 is a positive 2. Now how can I know if I did the right thing? Let's look inside the parentheses. Are they exactly the same? Yes. So that would be my first factor. My second factor is going to be those GCF I took on the outside along with the sign. So that would be 3x minus 2. And that's how you factor using the grouping method. Now please pause the video and try this one on your own. Just remember, check if there's a GCF first. Factor out the GCF and then factor the trinomial using the grouping method, since I didn't teach you any other method yet. Now I hope you tried this problem on your own. Now let's start by factoring out the GCF. Now how did I know that there's a GCF? If I look closer at the A, that's an even number. The B is also an even number. The C is an even number. So it looks like there's a 2 common between them. So I'm going to take 2 as a GCF. Now 8 divided by 2 is a 4, so that's 4x to the power 2. 8x divided by 2, that's a 4x. And negative 30 divided by 2, that's a negative 15. Now let me check if there is anything else in common. This has an x to the power 2. This has a variable x. This does not have a variable, it's a constant. So there's no x in common. Now let's look at the numbers one more time to make sure I factored everything correctly. Now this is an even number, even, this is odd. So 4 and negative 15, there's nothing else in common. So 2 is my only GCF. Now let's look closer at the trinomial that's inside the parentheses. I can see that this is a trinomial where a is not 1. So I can use the grouping method to try to factor this. So I first start by multiplying a times c. So let's recognize what a is, which is a 4, b is a 4, and the c is a negative 15. I need two numbers that would multiply to give me a times c, which is 4 times negative 15 in this case, and that's a negative 60. And I need two numbers that would add to give me the b, which is in this case a 4. So remember to find as many factors as you can for negative 60. So you would find those two numbers that would add to a 4. So what multiplies to give me negative 60? I can directly jump to 6 and 10, because I know 6 times 10 is 60. And since it's a negative 60, then one of those numbers, the 10 and the 6, has to be a negative. So 6 times 10 is a 60. I want a negative 60, so I'm going to put one of them to be the negative. 6 times negative 10 is a negative 60 now. Now if I add those two numbers, that will give me a negative 4, which is not what I want. I want positive 4. So I just switch the sign for those two numbers. Now negative 6 times 10, that's negative 60, and negative 6 plus 10, that's a positive 4. So these are my two numbers. After I find the two numbers, I can use different methods to continue factoring. But we're going to be using the grouping method now. So what I do is I copy down the first term. I'm going to split the middle term into those two numbers. So negative 6x, don't forget the x, and plus 10x. Because look guys, if you combine those two terms, negative 6x plus 10x, you will get 4x. So you're not really changing the expression. And now copy down the constant, negative 15. Now, I didn't forget about the 2. We'll come back to it later. So once I factor the trinomial, I can put 2 in front of the factors that I find at the end, okay? But don't forget about the 2. Now let's move on. I group the first 2 and the last 2 terms, and I try to find the GCF between these 2 terms. So 4 and 6, I can see that there's a 2 in common. This is an x to the power 2, and this is an x, so there is an x in common. 4 divided by 2 is a 2. And since I factored x out of the x to the power 2, so there's an x left. Don't forget to copy the sign, which is a minus in this case. 6 divided by 2 is a 3. Now, there's an x over here, but I factored it out, so there's no x that goes with the 3. And that's how you find the GCF. Now let's move on to the next two terms, to the next binomial. 10x minus 15. 10 is divisible by 5. 15 is divisible by 5. This has an x, but this does not have an x. So the only GCF in this case is a positive 5. Now, why did I write positive 5? Because the sign of the first term in this parentheses is a positive. So that's why this is a positive 5. Now, open parentheses. 10 divided by 5, that's 2, so 2x, minus 15 divided by 5 is a 3. Now let's check. This and this binomial, they are exactly the same. So that means I have taken the GCF correctly. Now, I still have one more step, which is to take the GCF, 2x plus 5, as one of your factors, and then the common factor over here, which is 2x minus 3, will be your second factor. And you write it only once. You don't put to the power 2 over here, because this is a common factor, so I write it down once. And that's how you factor this trinomial. Now, don't forget to copy down the GCF that you have taken out earlier, which is a 2 in this case. And now this is how you factor such a trinomial. Now, how can you check your work? One way is to actually distribute the 2 and then to FOIL whatever you get over here. Now, if you have access to a calculator, you can put the original standard form or the original equation in y1 and your factored equation in y2 and graph it. If you see the same parabola or the same graph, then you have factored correctly. If you see two different graphs, then that means that you have made a mistake somewhere, and you can go back and check your work. And that's the end of the grouping method. Now we will learn another method to factor trinomials. Now I want you to know that the grouping method and this method works for any type of trinomial. And even it works for binomials, because like if you want to factor something like this for x squared minus, let's say, 9, the a is 4, yes, the c is negative 9, but the b is not there, so I can put the b as being a 0. So you can still use the grouping method or factoring method to factor something like this. However, if you use the difference of two squares, and then you can know right away that the two factors are 2x minus 3 and 2x plus 3, and that would be faster if you recognize the pattern. However, if you forgot how to factor using the difference of two squares, you can always use this method or the grouping method. So again, this method, which is called the bottoms up method, and the grouping method works for any type of trinomial, and it works for binomials like this. Okay, with that said, let's see how this works. Now I like this method because it's quick, especially when we get to polynomials later on. in quarter 3, and you need to factor a couple of problems in one problem. So you need something quick and simple, and this is a quick method if you understand it. So what do we do to use the trick method or bottoms up method? You always start the same way. Whenever you look at the trinomial, in this case 2x to the power 2 minus x minus 15, you always multiply a times c, and that is a negative 30 in this case. So you want two numbers that would multiply to give you a c, which is negative 30, and add to give you b, which is a negative 1 in this case. So you start the same way as the grouping method. Now let's figure out what those two numbers are. So negative 30. What multiplies to give me negative 30 and add to give me negative 1? Now the two numbers I'm thinking of are negative 6 and 5, because negative 6 times 5 is a negative 30, and negative 6 plus 5 is a negative 1. So the two numbers are negative 6 and 5. So far there's no change. Now what happens after here is how this method is different from the grouping method. Once you find those two numbers, negative 6 and 5, you try to divide by a. Now a in this case is a 2, so you're trying to factor out the 2 from negative 6 and 5. So then you have negative 6 over 2 and 5 over 2. Once you divide by a, try to simplify the fraction if it's possible. So negative 6 divided by 2 is a negative 3. 5 over 2 is not factorable, so I don't want you to put a decimal. You cannot simplify this fraction. So don't divide 5 over 2 and put 2.5. Keep it as a fraction. And it's a positive fraction, so let's put plus 5 over 2. So once you divide by a, so put the number over a, and simplify the fraction if it's possible, then put x in front of each of those numbers, and those will be your two factors. So x minus 3 is my first factor, and x plus 5 over 2 is your second factor. But if you have a fraction left, or if you have a bottom to this fraction, take it up and put it next to the x. That's why it's called the bottoms up method. So x minus 3, and now it becomes 2x plus 5, and that would be your second factor. Quick, easy, to the point. Okay? Now to check your work, you can always distribute or FOIL, and you will see it's exactly the same. It will give you 2x to the power 2 minus x minus 15. Now I would like you to pause the video and try the second trinomial on your own using this method. The first thing I should do is check if there's a GCF. So I have a 12, a 4, and a 1, so there's nothing in common. I have x to the power 2x, and there's no x, so there's no x in common, so there's no GCF. Now I check if x to the power 2 has a coefficient, which is 12 in this case. If the coefficient is 1, then that would be a mental math problem. I just think of the two numbers that multiply to give me c and add to give me b, and I'm done. However, if there's an a, you have to multiply a times c, which is in this case a negative 12. So you need two numbers that multiply to give you negative 12. And two numbers, the same two numbers, should add to give you negative 4. So what multiplies to give me negative 12 and add to give me 4? I'm thinking of 6 and 2. 6 times 2 is 12. Now one of them has to be negative because I have a negative 12. So if I add them, they have to give me a negative 4. So then the 6 should be the negative. Let's try. Negative 6 times 2 is negative 12. And negative 6 plus 2 is negative 4. Exactly the same as the grouping method. Now, what happens next is different. Once you find those two numbers, you divide by a, which is in this case a 12. So you divide by 12. Now simplify the fraction if it's possible. So 6 and 12, 6 over 12, will simplify to a negative 1 over 2. 2 over 12 will simplify to 1 over 6. So my two numbers are negative 1/2 and positive 1/6. put x in front of each of the numbers, and these will be your two factors. But there's one more thing you need to do. Bottoms up. If you are left with a fraction, the bottom of the fraction should go in front of the x. So 2x minus 1 and 6x plus 1. Now remember to check your work. You can always FOIL to see if this factored form will give you the trinomial 12x to the power 2 minus 4x minus 1. Let's check. 2x times 6x, that's 12x squared. 2x times 1, that's 2x. Negative 1 times 6x, that's negative 6x. So combine those two. Negative 6x and positive 2x, that's negative 4x. Negative 1 times 1, that's a negative 1. So that would be my factored form. And that's the end of the second method, which is the bottoms up method. Now let's move on to the next part of the lesson, which is factoring special cases in trinomials. Now before I start presenting this lesson, I want you to know that this is a mere shortcut. It works only if you can recognize certain patterns in a trinomial. So there are certain rules that you need to follow, and it only works if it's a perfect square trinomial. So this by no means works for all trinomials. What we learned earlier, which is the grouping method or the box method, or even the bottoms up method in PreAP, those methods work for all trinomials. So let's say you want to use the box method to factor that, you will arrive at the same conclusion that we will get to in this lesson. So if you don't want to use the perfect square trinomial, that would be fine. However, if you recognize the pattern, then factoring will be much faster. So let's see how we can find this pattern. Now there are certain rules that you need to follow, or certain things you need to check before you can know if you can apply this special case, or if this is a special case. Now the first thing you need to ask yourself, do I have 3 terms? Is this a trinomial? So let's check. We have 1, 2, 3 terms, so yes, it is a trinomial. Now the second thing I need to check is I need to look at the first and third term and ask myself, are they perfect squares? Now to know that, I need to look at the first term first. Now 4, am I able to square root that? What's the square root of 4? So if you have access to your calculator, find that square root of 4 is a 2. Now yes, it has a variable, and the power of the variable is 2, so yes, it's a perfect square. So then if I square root for x to the power 2, I will get 2x. Now 9 is also square rootable. If I find the square root of 9, I will get a 3. So yes, the first and the third term are perfect squares. So let's put a check next to that. Now the third thing I need to check for is, what if I multiply 2x times 3? What will I get? 2x times 3. That's a 6x. So if I multiply 2x by 3 and 2, I need to double it. So 2 times 2x times 3, that will give me 12x, which is the middle term. So all 3 rules are satisfied. Let's review what they are. Now again, when you understand this lesson, it's not going to take you this long to do it. You can directly look at the numbers and recognize that. And once you recognize the pattern, then factoring will be very fast. Now we have 3 terms. Check. The first term is square rootable. I can do square root of 4 and I can get it to 2. Now the third term is also square rootable. If I square root 9, I will get a 3. So check. Now let's look at the third one. I need to see if the middle term satisfies a certain pattern. Now if I multiply 2 times 3, that's a 6, and double it. So 6 times 2 is 12. So the third rule, check. That means this is a perfect square trinomial. I use the sign of the middle term, put it between the 2x and the 3, put parentheses around them, and put a square on top. So that means that my factored form is going to be 2x plus 3 to the power 2. Now, how can you check your work? Always put the main question in y1, or the main equation in y1, put the factored form in y2, and graph it. If you get the same parabola, then this is your answer. You are correct. Now let's move on to number 1. Let me try number 1 with you. So let's see. Are these 3 terms? 1, 2, 3. Check. Can I square root 49? If I square root 49, I will get 7. Now you see how the 49 has a variable x to the power 2, so I give the 7 only an x. Now look at the third term. It's 25. Can I square root it? Yes, I will get a 5. So, second rule, check. I was able to square root 49. I was able to square root 25. Now I need to check if the middle term satisfies the pattern. Now multiply 7 times 5, so that's 35. Then double it. 35 times 2 is a 70. Check. So then I'm done. I use the sign of the middle term, put it between the two terms 7x and 5, put parentheses around them, and then put 2 on top. Now I would like you to pause the video and try number 3 on your own. Now I hope you tried on your own, and I want you to see how this is a shortcut. Very fast. I didn't have to do the box method or the bottoms up or grouping because it satisfies a certain pattern, and I was able to factor quickly. Now let's see. Do we have 3 terms? Check. Can we square root the first term? What's the square root of 9? 3. And you see how the first term has a variable x to the power 2, so I give the number 3 just an x. Now let's look at the third term. Can you square root that? What's the square root of 4? It's a 2. So yes, I was able to check the second rule. Now let's see if the middle term follows a certain pattern. Now multiply those two numbers by themselves. So 3 times 2 is a 6. Now double that. 6 times 2 is a 12. So check. Satisfies the third rule. What's the sign of the middle term? Positive. So I put plus between the 3x and the 2, and then square on the outside. That means my factored form is 3x plus 2 to the power 2. Now if you want to check that, you can write it like algebraically. You can write out 3x plus 2 twice and FOIL it, and you will get exactly that. Or you can put this in y1, your factored form in y2, and you will see that they will be equal to each other. So this only works if you have a perfect square trinomial, if it satisfies 3 different rules. Now let's move on to number 2 and try this together. Now, first of all, do we have 3 terms? Yes. Can I square root 36? Yes. What will I get? 6. Now, you see how 36 has a variable x to the power 2, so I give the 6 a variable which is x. Now let's look at the third term. Now, I don't have a number, but that means that the number is 1. So check. Can you square root 1? Square root of 1 is a 1. Check it. Now, you see how, if they didn't give you a number, you put the number. It's there. It's 1, but you don't see it. So you can put 1. Square root of 1 is a 1. Now, you see how 1 has a variable y squared. So I give the 1 over here just 1y. Because remember, we're going to put the square on the outside if this turns out to be a perfect square. We don't know yet. We have to check if the third rule works. Now, multiply these two together. 6 times 1 is a 2. 6 times 1 is 6. Now multiply by 2 and you get 12. So the third rule is satisfied. Now look at the sign of the middle term. That's a minus. So I put minus between them and I put square on the outside. So then my factored form is 6x minus 1y, which is just a y to the power 2. And that would be my factored form. Now, do I have to use this method? No. You will arrive to the same conclusion if you use any of the other methods we learned. But if you recognize the pattern, then factoring will be quicker. Now for the pre-AP students, remember I would like you to memorize those rules, okay? Because when I give you a minus b to the power 2, I need you to be able to distribute and factor quickly, and I don't want you to be writing a minus b twice and foiling them. So you need to know these two rules.